Morning.
Good morning.
Good morning.
Good morning. Hey. Okay, ladies. Any questions? Does anybody have any questions? Then we can mainly, it's okay, just carry on and talk about impedance. And the impedance that's going to, we can say is okay, the resistance that sound wave experiences. Okay. As it, we can say it's okay, travels through medium. Clear. So you can say if this, for instance, okay, here was a medium. In our case, yes, okay, that's going to be, you can say it's okay, any tissue. And we have a sound wave. The most likely is okay, also is okay, once it hit this medium here, it's okay. But some of the energy is going to, it's okay, reflect back. Clear? Some. How much, we'll get to that in just a little bit. Okay. But what remaining can say is that, okay, some of this sound wave, which actually is okay, travel towards the medium, is going to, it's okay, travel through the tissue. And we can mainly say, okay, that resistance that mainly is okay is offered by this tissue here to the sound wave. That is going to be, it's called impedance. Okay. So it's mainly going to be as okay, the resistance that okay, as any tissue is going to offer to a sound wave traveling through it will be referred to as the impedance. Is that clear? Just like, yes, okay, if you, for instance, okay, are sitting in the classroom or in any room, and yes, okay, you want to leave the room. Clear? Okay, now that resistance that you may experience to, yes, okay, leave the room is going to be, yes, okay, the door. Okay, now that can be, yes, okay, a low resistance, that can be a greater resistance, that can be, yes, okay, a very great resistance that you may experience as, okay, when, because it's okay, leaving the classroom or leaving any room through the door. Now, for instance, go, yes, okay, if that door is open, if it is an open door, what will you have? You're going to just, okay, experience the least resistance. Because what you mainly can do is you can mainly just, okay, just walk through the door. Clear? Whereas, okay, yes, if that door is just open half the way, right, okay, what that is going to do is, okay, mainly is, okay, offer you a greater resistance compared to, yes, okay, the open door. Clear? You can even say, okay, that resistance may increase if there are somebody is, okay, standing on the other side, pushing onto this door here. There was me, yes, okay, going to, you can say, yes, okay, be a tug of war between, yes, okay, you trying to open the door here, and okay, yes, the person who was standing on the other side and actually is, okay, pushing against the door. But even if there was nobody, you can mainly say, okay, what you mainly would do is you mainly just, okay, slow down, because you can say, well, okay, I can't just run through the door as it was, what the case when the door was open. So yes, okay, you may, it's okay, experience, you can say it's okay, a little more resistance here, or we can say it's okay, impedance. Whereas, okay, yes, if the door is closed, then yes, okay, there will be a greater impedance. Not to talk about, yes, okay, if that door was not only closed, but also locked. Does that make sense? Now, if that was the case, you mainly would say, well, okay, yes, well, okay, I don't really have the key to open the lock. So yes, okay, you can say, it's okay, after pushing onto the door and trying to opening it, moving on the handle to see, it's okay, if that will, as okay, make it any easier, you most likely, it's okay, well, that's not going to open, let me just go back and sit on my chair again. Clear? Okay, so what we mainly, yes, okay, will get from the, yes, okay, impedance. That we can mainly say, yes, okay, the greater the impedance, that, okay, yes, a tissue is going to offer to a sound wave, which means, yes, okay, is going to mean, yes, okay, that the tissue here is, okay, offers a greater resistance to the sound wave. That would be just as I say, it's okay, not only was the door closed, but it's okay, it was even locked. Clear? And what is going to happen is, okay, you as a sound wave, or yes, okay, as a person as a whole, yes, okay, may go back and say, well, okay, I'm not really going to be able to just, okay, pass through this tissue here. So greater the impedance goes, we can mainly say, okay, that will mainly lead to, yes, okay, a greater amount of energy reflected back. Like this. Clear? And we can say it's okay, the more energy reflected back, That means it's okay going to cause that, okay, as this tissue here is okay, may appear brighter on your image. Whereas on the other hand, if you say it's okay, if we talked of lower impedance mainly means that, okay, this tissue here offers us, okay, a lesser resistance to the sound wave or to the sound energy that hit it. I mean, as we're going to let most of it just, okay, travel through. Because of a lower resistance, that will mainly cause that, okay, yes. In that case, it's okay, what we may have is we can say, okay, the weakest reflection. And that is actually, it's okay, going to appear, we can say it's okay, the darkest on your scans. Clear? Whereas you said is okay, a tissue, for instance, yes, okay, let me just take this off here. It's okay, it's still a tissue. It's just going to be, it's okay, consider it a different tissue. But it's okay where the impedance is, well, okay, as we can say, it's okay, an intermediate. Not as strong as this, not as weak as this, but it's okay, it's something in between. Clear? That is mainly going to be, it's okay, that, okay, as some resistance is going to be offered. Okay. But not as strong as we had up here, not as weak as we had down here. And that's mainly going to be, okay, as we will have, okay, as a reflection that's not going to be as, okay, white as milk or black as coal, but, well, okay, yes, it's going to be as, okay, any shade of gray that will be created by that. Okay. Did that make sense? So it is pretty much going to be as, okay, the impedance of a tissue that will determine whether that tissue on your scan is going to appear bright, is going to be dark, or yes, okay, it's going to be, yes, okay, we can say it's okay, any shade of gray, either on the bright side of the grayscale or the light side of the grayscale. Okay, all dependent upon, yes, okay, the amount of impedance that it offers to the sound wave. Okay, because if energy, yes, okay, can't travel through, yes, okay, a medium, it most likely, yes, okay, is going to, yes, okay, reflect back. But just as, okay, use this here as, okay, as an example, like, okay, the door is closed. Well, okay, yes, you'll probably not be able to just, okay, leave the room and walk into, yes, okay, either the room next door or, yes, okay, into the corridor or hallway or whatsoever. Whereas, okay, if the door is open, yes, okay, the only thing that you need to do is push on the door. Or open half, okay. Okay. The only thing that you need to do is, okay, is push on the door. Okay. Where, okay, so the door was open and, okay, widely open, yes, okay, there was no resistance at all. So you can make it, okay, just walk straight through. Okay. But because that's okay, it's diagnostic importance. So importance is going to be as, okay, that it means it's, okay, going to be the impedance that will determine whether it's, okay, a shade of a tissue on an image is going to appear bright, dark, or whatever shade in between is, okay, bright and dark. Is that clear? Okay, so just remember, yes, okay, the greater impedance, yes, okay, most likely is that, okay, yes, that's more energy will make yes, okay, a U-turn and return back. Whereas, okay, lesser resistance, that's okay. Lesser energy will reflect back, and okay, we can say it's okay, more energy will move ahead or travel ahead, if you want to put it that way. Okay, mainly as okay, just okay, come across, you can say it's okay, another medium, which then will have its okay, its own impedance. Clear? Which will mean that it will offer yes, okay, its own degree of resistance to yes, okay, the sound energy here, and cause more or less of it to reflect back, and okay, yes, the remaining yes, okay, just to continue. Did you girls get that?
Yes.
Okay. Right. Okay. Now the unit for impedance. Well, okay, we can say it's okay. The basic unit that was that's going to be as okay rails. Clear? Now maybe it's okay because it's okay here in, you can say it's okay ultrasound. It's okay, the sound is going to experience as okay great amount of okay as resistance. You can mean it says okay, that's going to just okay be in mega rails. Okay, so ultrasound is okay, is going to just okay experience like I come across resistance, which is going to be measured in mega rails, which means it's okay, where mega here means it's okay, it just means 1 million rails. Clear? The symbol for this one is going to yes, okay, for rails is mean yes, okay, just expressed in the letter Z. Is that clear? Okay. Now, what mainly is going to yes, okay, determine impedance. Well, okay, as it was in the definition itself, because okay, it is the resistance offered by the medium through which the sound, in this case, yeah, that's okay, travels. So it's mainly as okay, going to be as okay, the medium. Or we can say it's okay, the nature of the medium that will determine how much resistance that it will offer to the sound wave. Is that clear? Okay. Any questions, ladies?
No.
Okay. And okay, as it may sound crazy, but it's okay. This is okay, impedance. That's going to be as okay, something that we'll talk about again in a later chapter as well. Where you can mean it says okay, still that's going to be as okay. The resistance that okay as a medium will offer to the sound wave, and the greater that resistance is, most likely is it that okay as that sound wave will, or more an amount of okay as sound energy is going to just okay make a U-turn and travel back. Okay. But since it's okay, we mean it's okay. In this chapter here, we mean to talk as the medium is okay, being the tissues. Okay. But as okay, the impedance is going to is okay be a topic that comes up again in an in a later chapter. Right. The last thing that you guys just have to remember about impedance is that it is mainly going to be, that's okay. It's mainly as something that is going to be calculated. Okay, so the mainly is a formula for it or equation for it. But it mainly says that impedance is that's going to be the equal to the product of two things, which is mainly going to be the density. And here we can say, that's going to be the density of what? Yes, in this chapter here, the tissues, or generally speaking, the medium through which the sound travels. Clear? Okay. So that's going to be one of the factors that as will determine the amount of impedance that a tissue will offer to a sound wave or the resistance. The second is going to be the propagation speed. Which we already said in as a previous chapter that I was going is the only of your 7 parameters which was wholly and solely determined by the medium, right? Which we in this sense can say would be the tissues. Okay, but we can make says that the value of impedance is made as going to be as calculated by multiplying as the density of a tissue and the propagation speed of a tissue. Okay, where from this equation here we can mainly as say that it's going to as that the greater the density, the greater will be the impedance, and or the greater the propagation speed of a medium, the greater will be the impedance. Clear? Whereas you can just go vice versa and say, yes, the lower the density of a tissue, the lower the impedance. And as as the lower the propagation speed, the lower the impedance. Did you guys get that? And what did it mean to have a greater impedance? That may just lead to more energy deflected, which mainly would lead to that this tissue here was going to appear brighter on a scan. Whereas the opposite was just going to be that it says lower impedance, that will mainly mean that yes, lesser energy is reflected off Yeah. Which means, okay, we'll cause that, okay, as that tissue appears darker on a scan. Okay. Did you guys get that? Now, just one thing. Okay. Because what determined your propagation speed? Yes, girls, what determined your propagation speed?
The source.
The medium.
Okay. Who said source? Who was that?
Oh, sorry, that was me.
That was you.
I meant
Okay.
to, I meant to medium, sorry.
Okay. So it's the medium and medium only, right? Okay. But not that, okay, we can make this, okay, we can say, okay, we're going to be as, okay, the two characteristics of the medium that determines the propagation speed.
Stiffness and density.
Warm it up.
Is it stiffness and density?
Stiffness and density. Okay, so mainly because well, we already have density here. Clear? But mainly as okay, because stiffness is directly as okay determining as okay your propagation speed. That's why it may as okay indirectly, because it's okay play a role in okay as determining the impedance. And we can make it as okay, as we just said when we talked about as okay, that okay, as the greater the stiffness, the greater will be the propagation speed, and lesser the stiffness, lesser the propagation speed. Okay, although yes, okay, stiffness is not yes, okay, directly mentioned yes, okay, here in the equation, but mainly because it plays a role in determining the propagation speed. It may has okay have a role in determining the impedance. Okay. Well, just remember that okay, as impedance is okay as the product of two parameters, density and propagation speed. So if either of these is higher, that means okay cause an increase in the impedance, either or both. Whereas if either or both of these two factors, you have density and propagation speed, are low, that will decrease the impedance of a medium. And what does that mean? That the greater impedance is going to mean that okay, as it offers a greater resistance. And that greater resistance meaning offered by the tissue is meaning going to cause that more amount of okay as the sound energy that hits the tissue is going to okay reflect back. And that is actually going to cause that tissue is okay on your scan will appear brighter because it's made up of yes okay more sound energy. that, okay, as all your image becomes, yes, okay, we can say, is displayed as a brighter color, or brighter shade, sorry, and vice versa. Did that make sense? Just remember, yes, okay, each unit is going to, yes, okay, basically be rails, but that's okay in ultrasound, at least in this course, yes, okay, we'll talk about mega rays, which is going to be, yes, okay, millions of rails. Okay, but the main thing that it determines is this. Okay. Did you girls get that? Yes, girls. Anybody who is in doubt? Okay, girls, there are some 17 questions on page 89 and 90. Okay. Please take at least, okay, take 10 minutes to try to just, okay, answer these questions. And I'll be back with you then. Should we say around 9:50?
Okay.
It will not produce an echo. But what is an echo? Mainly, it's okay, just a sound that reflects back at you. A visual form of reflection is okay as what you see in your mirror. You see your own reflection. That is what you see. So that's mainly as okay, just the energy that you are emitting that is reflected off the mirror, which is okay here is going to act as a reflector because it produces a reflection. Just like a tissue boundary. Sound hits, some of that sound is going to just okay reflect back. Now, when I say some of that sound is going to reflect back, that's okay, it's going to be the how much sound. Actually, it's okay, sound energy. Or when we say reflection, means it's okay, just because they're traveling in the opposite direction as the incidence. And whatever is going to be left, continue. when that's okay, that continuing amount of energy is going to be as okay, or because the continuing wave is going to be referred to as a transmission. But mainly because, okay, that transmission heads towards a new boundary. Or we can say, okay, tissue that may lie deeper. That transmission becomes a new instance. Any questions? Nope. So if we say as okay, one tissue straightly as okay, if we just say okay, we had one transducer here. Yeah. We just had okay, yes, one boundary. Well, okay, this here is the incidence. This here is your reflection. And this is your transmission. So generally to speak, it's okay, what was the incidence? The sound wave, or in this case, because okay, for us, it's okay, the sound wave that traveled towards a boundary. So it's okay, your book may, yes, okay, use the word boundary to begin with. But what that boundary actually means is a tissue. And yes, okay, they may even, yes, okay, call it, yes, okay, later on, yes, okay, a reflector. Why? Because that's okay, when that incidence is going to, yes, okay, hit this boundary here, it is going to, yes, okay, produce a reflection. Or create a reflection. And what is going to be reflection? Just part of the energy, greater or lesser amount of energy that the incidence was carrying is going to return back. Whatever is left will continue as a transmission. Now, if we, for instance, okay, had okay as another boundary, then we can make as okay, this transmission here is okay, also is okay, again is okay, just becomes an incidence, because what is that it did? It did what the first incident did. Travel towards a boundary, travel towards a tissue, travels towards us, okay, a new reflector. Why would it be a reflector? Because okay, when this sound wave hits, it will produce a reflection that just does the same as what the previous reflection did. Travel back. What is left becomes just okay, carries on as a transmission. Which again is okay, as I said, is okay, travel towards as okay, a boundary or a tissue or a reflector. Can now as okay, also be considered as an incidence. Where, okay, when it hits this boundary, it's okay, will produce a reflection. So actually, that's okay, the only new term here which is not used in daily English conversations is incidence. When you say it's okay, a radio transmission, what is that? That's mainly it's okay because it is sending out the signal, right? And as I say, it's okay, a visual form of a reflection is okay as if you look at the mirror, you see your own reflection. So the only thing you need for a reflection is okay as something that is going to be reflected and a reflector. For us, yeah, ultrasound is okay, or reflectors is going to be as okay the tissues. Because they will produce a reflection, which is that's going to be as okay amount of as okay, some of the energy that the incidence carried towards that reflector tissue or boundary. That was going to say, okay, get a reflector back. And that amount of energy was determined by the different impedances between the media. So the actual the only new term here was incidence. Clear? Now, to begin with, girls, okay, yes, that's again, yes, okay, something that we will come across, or yes, okay, at least talk a lot about, especially that's okay towards the end of this chapter here. It's going to be as okay, what we can call as okay, the incident angle. And again, it's okay here, it's okay angle, it's okay, anybody who have done some sort of okay as geometry would know what an angle is. Clear. So what we made is okay, we'll call an incident angle that is going to, we can say it's okay, the angle is okay, formed between, we can say it's okay, the incidence and the tissue boundary. Or we can say it's okay, the tissue. Now just keep in mind here, it's okay, girl, tissue is not the standard word. It can be as okay, boundary. It can even as okay, be as okay, reflector. So that will be as okay, your incident angle. Which means your meaning as okay, which would be the angle that, okay, as is going to, yes, okay, be formed between, yes, okay, the tissue here. And let's say, yes, okay, your incidence. Clear? Very mainly can say, yes, okay, this here. That will be, yes, okay, your incident angle. Because what is it that it is? It's going to be, yes, okay, the angle that is formed between, yes, okay, your incidence and what was the incidence? Yes, okay, the sound wave traveling towards the tissue and the tissue itself. Did you guys get that? Did you girls get that?
Yes.
Good. Now in this instance here, it's okay, we can mean it says okay. This angle here is okay, that is what we'll call is okay, a 90-degree angle. Okay, mainly because okay, if this was your incidence, and this here is okay, was your tissue. That is going to be okay, what we call this kind of angle here is a 90-degree angle. Okay. So that actually is going to be okay, the amount of degree angles that we have in this angle here is going to be 90 degrees. Right, geometrically, right, yes, okay, this 90-degree angle, yes, okay, can also, yes, okay, be referred to as a right angle. So right angle is mainly, yes, okay, just another name or another term that is going to, yes, okay, represent what is going to be referred to as a 90-degree angle. This 90-degree angle and right angle can also, yes, okay, be referred to as a, perpendicular angle. Is that clear? Likewise, that's okay, can also be referred to as an orthogonal angle. Yes, okay, all these terms, yes, okay, mean the same. They all mean that, okay, yes, that the angle between the incidence and, yes, okay, your tissue were, yes, okay, at 90 degrees. Or the angle between, yes, okay, tissue and incidence was 90 degrees. That 90 degrees can also be referred to as being a right angle. It can also be referred to as, can also be called as, okay, that is going to be as okay, a perpendicular angle and or an orthogonal angle. So it's okay, because it's okay. These three here mainly as just okay, just synonyms for it's okay, a 90-degree angle. A right angle is mainly as okay, just a synonym for 90-degree perpendicular, or it's okay, orthogonal angle. Perpendicular angle is mainly as okay, just synonyms for is okay, 90 degrees and right angle and orthogonal angle. Likewise, okay, as an orthogonal angle is just going to be as okay, a synonym for what we commonly known as an 90-degree angle, right angle, or perpendicular angle. Okay. Now, ladies, in terms of incidence, okay, we mainly as okay, we're come across as okay, we mainly as okay, we use the word that okay as a normal incidence. Okay, it's going to be we can use let me just sorry, change the color. You can say yes, okay. That's a normal incidence. That is actually as okay going to be as okay, we can say an incidence. And what was an incidence? A sound wave that travels towards a tissue boundary. Clear? Okay, that was what we call an incidence. Okay, but what actually is okay makes it normal. Okay, so an incident that creates a 90-degree angle. And we can just okay say as okay with the tissue. But that 90-degree angle can also be referred to as a right angle. You can even use okay word, use the word as okay a perpendicular angle. Or we can even use okay use the word orthogonal angle. Clear? Okay. Okay. But that incidence is going to be considered a normal incidence. Okay. So whenever yes, okay, an incidence, yes, okay, may travel and may hit a tissue boundary. And the angle between these two here is okay, yes, a 90-degree. Or a right angle, or orthogonal angle, or perpendicular angle. We actually, it's okay, call this incidence here is going to be referred to as a normal incidence. Did you get that? So if this, for instance, okay, was the tissue boundary, bam, that makes yes, okay, a 90-degree angle. Then this here would have been a normal incidence. Clear? Or we can say is okay, whenever there's a 90-degree angle or a right angle or perpendicular angle or orthogonal angle between the incidence and the tissue boundary, we will refer that incidence to be a normal incidence. Is there anybody who is in doubt about that? Okay, and the reason, girls, the reason that we call it a normal incidence is because for diagnostic imaging, and the reason I say it's okay, diagnostic imaging 3 times is that when your goal is to create an image, a 90-degree angle is the right angle, or we can say it's okay, is the ideal angle. Did you girls get that? When your goal is to create an image, then a 90-degree angle is the right angle or ideal angle. Just like, okay, as you want to see your own reflection in the mirror. What was it that I said you should do? Stand right in front of the mirror, right? Okay, and that's mean that's okay, what you do. You, yes, okay, being, yes, okay, here, yes, okay, the source that emits energy. That energy, yes, okay, hits the mirror at a 90-degree angle. And what do you get from that? The reflection comes right back at you and you are going to be able to see yourself in the mirror, right? Did that make sense? So yes, okay, ideally speaking, yes, okay. The ideal angle for diagnostic imaging is going to be 90 degrees. Now, is that always possible? No. Okay, now that doesn't necessarily mean that, okay, yes, you're going to missing out on structures. Okay. But it's okay, for it's okay, imaging, actually it's okay, visualize a thing, it's okay, the best angle is, or the ideal angle is 90 degrees. Any doubts? Now, girls. So a 90-degree, that was what we as okay mean. Yes, okay, just call it a right angle, we call it a perpendicular, we call it orthogonal. And when yes, okay, your incidence, yes, okay, makes a 90-degree angle with the tissue. That incidence here is going to be called a normal incidence. Then the next kind of angle. Now we can maybe say, okay, any angle which is not a right angle, which means which is not a 90-degree angle, or which was not a perpendicular angle, or is not an orthogonal angle. Is going to be known as being an, oh, huh? Okay. Does she have bathing suit now? Does she have bathing suit with her? Okay, just watch out for it then. Okay, it's going to be called a oblique angle. Okay, so we can mainly say, okay, this and these here is okay, that made that's okay, all right angles. Or 90-degree angle, perpendicular angle, exactly. Whereas we can say something like, okay, yes, this and this. This is not a right angle. Mainly because this is not 90 degrees. Likewise, we can also say as okay that This and this is not a right angle because it's not 90 degrees. So yes, okay, both of these here can be referred to as being oblique angles. So any angle which is not 90 degrees is going to be called an oblique angle. So in case that, for instance, okay, for incidence, let's say it's okay, that this here is okay was our tissue. And in case that, okay, as our incidence, for instance, okay, it's the tissue like this. That's a little bit quicker. Right, okay. For remaining, I say it's okay that this angle here is not an is not a normal angle, or we can say, okay, this would not have been a normal incidence because it's going to be as okay an oblique incidence because it produces an oblique angle with the tissue boundary. Clear? Now, as far as okay as oblique angles are concerned, that can mean it's okay be two varieties or two subtypes. Now, since it's not 90 degrees, it's going to be as okay, we can say it's okay, lesser than 90 degrees, which you may okay see here. This is lesser than 90 degrees because this here is okay, what had been is okay a 90-degree angle. So here's okay, this is a lesser than 90 degree. That lesser than 90 degree is okay angle is going to be referred to as being an acute angle. Yeah. Whereas if you on the other hand say it's okay, then what about yes, okay, this angle here? That's going to be as okay. It's still yet okay, not 90 degrees. But as a matter of fact, going to be something that will be greater than 90 degrees. And those angles which are greater than 90 degrees are going to be called obtuse angles. But whether they are acute or whether they are obtuse, they are both going to be as okay examples of being oblique angles. Clear? So in terms of incidence, we can call it as okay an oblique incidence, whether because it's not a normal incidence, or either because okay it produced an angle with the tissue boundary that was lesser than 90 degrees, or it produced an angle with the boundary which was greater than 90 degrees. Both of these could be characterized as being oblique incidences because they produce an oblique angle with the tissue boundary. Did that make sense? And why were these not ideal for diagnostic imaging? Yes, okay. This was your mirror. You were standing over here. Or this was your mirror and you were standing over here. What happened? If this was your mirror and you are standing over here, you would not be able to see your own reflection. But a person standing over here will be able to see your reflection, right? Did that make sense? Okay. So yes, okay, looking in the mirror. But this was mainly as okay, just geometry 101. So a 90-degree angle can also be referred to as a right angle, orthogonal angle, perpendicular angle. Clear? Okay. Or what do we refer to as okay? We may as okay say that that will be as okay a normal incidence. What do we mean by a normal incidence? That okay, the tissue and the sound wave makes a 90-degree angle, or right angle, or perpendicular angle, or orthogonal angle. Whereas, okay, as if the tissue and the sound wave makes anything but a right angle, that will be referred to as an oblique incidence, because it hits the tissue at an oblique angle. Okay. And what the effect of that oblique angle is going to be. That's going to be, okay, the last topic of our chapter here. Okay. Any questions about incidence, reflection, incidence, transmission? Incidence, reflection, and transmission. Where we should begin with mainly as okay, just say as okay, incident angle. Okay. Incident angle. Now you can mainly say, okay, incident angle is going to be the same as angle of reflection. Okay. But only if that incident angle is okay as a 90-degree, will the angle of incidence and angle of transmission remain the same. That's going to change once we talk oblique incidences. Okay. Any question? Yes, goes. Any
No.
has any questions?
No.
Okay. Well, let's do it this way. Now goes what we mean, you can say is okay, yes. What is this? Yes, ladies.
Incident,
Pump it up.
would that be considered? Hold on. The incident,
Okay. Yes, my dear. It is an incidence. Can you make it more specific?
when the sound waves is traveling to the
No,
boundary.
no, that's fine. Yes, Danielle,
Normal incidents?
it's a normal incidence, my dear, okay? Why is it a normal incidence? Mainly because here we have a 90-degree angle. Yeah. Now let us just assume that, okay, as this tissue boundary here, okay, offers certain impedance. And we have a reflection. This becomes, yes, okay, your reflection. Clear. Now what is made, yes, okay, just going to be left of sound energy after this reflection, yes, okay, may continue on the other side. And its first set here is okay, we can refer to this as being a transmission. But mainly as we see that, okay, this transmitted wave here, actually it's okay, also is traveling, it's okay, towards a boundary or a tissue here. We can say it's okay, then this means okay, just becomes just okay, incidence as well. But what we see here is that, okay, yes, that this angle here actually is going to, yes, okay, be greater than a 90 degree. Now, first of all, because it's anything but a 90 degree, yes, okay, that makes it an oblique incidence. Did that make sense? Okay.
Yes.
Now it may, yes, okay, reflect a certain amount of energy back. Okay. Now for now, although yes, okay, this is going to contradict, yes, okay, what we talk about later on. But we can mean, yes, okay, say, okay, stay, yes, okay. Yes, okay, reflect back like this. Although that's not going to be the case here. Okay. Now, and so is okay as what may happen here, because okay, that may also change. But let's okay, just assume that okay, as it still continued on straight like this. So this is okay, just becomes just okay. Another transmission, which means okay, just it travels as okay towards a new tissue boundary as okay, just becomes because it's okay, another incidence. Very community says, okay, here, this makes an angle that is lesser than 90 degrees. Because a 90-degree angle in this case here is, okay, would have been something like this. So that's a smaller angle, that's a lesser angle. So that means, okay, just makes this fellow here is, okay, being an acute incidence. Okay, but whether oblique incidence, whether it's okay, acute incidence, both of them were oblique incidences. And yes, okay, this may, yes, okay, because they'll say, okay, may, yes, okay, even cause some sort of energy. Yes, okay, being reflected back. Okay. Without talking much about is, okay, the angle of reflection. That's something we talk about later on. Any question, ladies? But mainly it's okay because of, okay, yes, XYZ amount of impedance at different boundaries. Or mainly it's okay comparing the impedance between of this boundary to this, or this tissue to this tissue, this tissue to this tissue, this tissue to this tissue. If those impedances are not the same, that is actually is okay what will cause the reflection to occur. Whereas if you say that, okay, yes, the impedance of this tissue here was going to, it's okay, be equal to the impedance of this other tissue here. If they are equal, or if they have the same impedances, then that's going to be, that boundary is going to, it's okay, produce no reflection. Okay. Yeah, by no reflection, you mainly mean that, okay, there's no energy that the incidence is carrying is going to just, okay, get reflected back. So if that is the instance, okay, we can mean it says, okay, the amount of energy of the incidence in this medium here, and as it carries on here, is going to remain unchanged. Until it's okay, come across, okay, where the impedance of one medium is going to be different on the other medium. That's going to, it's okay, be causing, it's okay, a reflection back. And that reflection, well, okay, yes, it's going to just okay, because it's okay, produce, okay, as a certain shadow on our image. That shadow may be bright, that may be dark, that may be very dark, that may be very bright. That's all going to be dependent upon, is okay, because it's okay, the difference of the impedances between, is okay, the two medias. Because, okay, a difference in resistance. Any questions?
No.
Okay, girls. Now just yes, okay, you can, I'm not going to start off with the next topic. And then okay, let's break in the middle of okay, yes, for your lunch break. So just go and take your lunch and I see you back at 12:30. 12:35. Okay, girls? Okay, girls. Welcome back. Now, before we start, any questions? Nope.
No.
Okay, girlies. Then let's carry on. Oh, what we mainly as okay just said was there's it. This is a transducer. Had a tissue boundary. Now we mainly said, okay, yes, a sound wave that hits this boundary. That's okay. That was what we call the incidence. If we also say that, okay, yes, a this tissue boundary here, yes, okay, some energy is going to, yes, okay, get reflected back. We call that the reflection. And whatever is left will continue on as the transmission. Now, girls, ever since, yes, okay, we started talking about this chapter, we mainly said, okay, yes, that the energy is decreasing as the sound wave proceeds. Now, what we also is okay, already have said, okay, is that okay, as a measurement of how much energy can be expressed in either terms of power which also is okay, was going to be as okay directly proportional to the intensity. Clear? And either of these is okay here. Whether it's the power, whether it's the intensity, will mean as okay decrease as the sound wave propagates. And actually, that's like what this decrease here is okay that we called attenuation. So we can mainly say that, okay, as in this instance here, it's okay. Now, for the discussions that we're going to use, okay, we just going to just okay use as okay the term or refer to as okay the intensity. Well, as you already can see, as okay, as the intensity decreases, the power will decrease. As the power decreases, as the intensity decreases, so will the amplitude. So in this case, we can mean says okay that okay as the intensity of the incidence that is going to be greater than okay as the intensity of the transmission. Why? Mainly because okay, what the incidence did was it lost some energy in terms of in the form of reflection. Or we can mainly say, okay, some of the energy that the incidence was carrying was going to just okay get reflected back. So this reflection here is actually just okay, all going to have it's okay its own intensity. Did you guys get that?
Yes.
So in this case, I mean, you can say it's okay that the difference between the intensity of the incidence and the intensity of the reflection, that is going to be equal to, yes, okay, the intensity of the transmission. Or, at another hand, we can say that's okay. The difference between, yes, okay, the intensity of the incidence and the intensity of the transmission, that is going to be as okay equal to the intensity of the reflection. Or, as a matter of fact, we can say that, okay, yes, the sum of the intensity of the reflection and intensity of transmission is going to be as okay, be equal to the intensity of the incidence. Did that make sense? Okay, so this mainly as okay, just mainly as okay is all about as okay where we is okay. We can maybe it's okay just talk about it now. Although it's okay, your book talks about it later on and later on. It's going to be as okay, me it's okay, just confirming what we can say as okay will be the law of conservation of energy. Very main is okay, just in the first part of that could say as okay that energy can't be reduced, or destroyed. And it's pretty much okay as the conservation part is mainly going to be okay based on this. Which mainly mean that okay, yes, that we can say okay, the energy of the incidence there was going to be as okay equal to yes okay the energy of the reflection and the energy or power or intensity of the transmission. Clear? Where we then also could say that okay, yes. Okay, now here's okay, we mean yes okay. In all instances, okay, when we talk energy, we just going to just okay refer to as the okay intensity. So intensity of the incidence is going to be equal to the sum of the intensity of reflection and intensity of transmission. Why? Mainly because we said this intensity is okay, that was mainly as okay of the incident, all mean as okay what was produced by the transducer. Whereas okay, as when it came to yes okay to a tissue boundary, because it's okay, the paths of yes okay, the energy carried by the incidence took their own paths. Clear? Some of it was reflected back, some of it carried on. But we can mainly say is okay that the sum of these two here was going to be equal to this. And that's mainly as okay what we just wrote here. There we as okay, then on the other hand, just could say as okay that okay, yes. If we as okay say that the intensity of the incidence and from there just okay, we subtract the intensity of the reflection. That is going to tell us, yes, okay, what is going to be, yes, okay, the intensity of the transmission. Or if we let's say it's okay, the intensity of this incidence, but it's okay if you subtract the intensity of the transmission from that. That is going to mean is okay, well, okay, how much energy of what the incidence carried was actually as okay going to be as okay reflected. Which means okay will just be as okay the intensity of the reflection. Clear. Which means yes, okay, just was that okay, yes. The intensity of this is always going to be as okay equal to the sum of these two here. Oh, sorry. Okay. Or we can say it's okay, the intensity of this one here is always going to be as okay the sum of these two intensities of the reflection and the incident transmission. Clear? Where okay, as the difference of the incidence and reflection is going to tell us how much energy is being transmitted. Whereas okay, as on the other hand, the sum of is okay, the difference between the incidence and transmission, that is going to tell us okay how much energy was reflected. Did you girls get that? And as we said, so it really doesn't matter whether, okay, yes, whether we refer to, yes, okay, the intensity of the incidence, or whether we talk about, yes, okay, the intensity of reflection, or whether we also, yes, okay, talk about, yes, okay, or refer to, yes, okay, the incidence of the transmission. They are all mainly, yes, okay, just intensities of, okay, yes, the different forms of energy, which is going to, yes, okay, be expressed with the same unit as intensity, which would be any unit of power or any unit of area. Any unit of area was going to be, yes, okay, we can say, is okay, any unit of distance being squared. Clear? Or very main, yes, okay, can say that, okay, as the sum of these two here will equal this. Clear? Whereas, okay, yes, this incidence and reflection, the difference of those two, or when we subtract those two from one another, is going to, yes, okay, be equal to the intensity of the transmission. And or the difference between, yes, okay, the transmission and incidence will be equal to, yes, okay, the intensity of the reflection. Did that make sense? Yes, girls, did that make sense?
Yeah.
Yeah.
So your straightforward calculations is mainly, yes, okay, just going to be that we said this was a transducer. We could say, yes, okay, we had a medium. We can say, yes, okay, we have a medium. We have a medium. We had an incidence. This has a certain intensity. That will be referred to as, okay, as the intensity of the incidence. At a boundary, some will reflect. So that's going to be as, okay, the intensity of the reflection, the amount of energy that's going to be reflected back. And what is carrying on is going to have its own intensity, which will be just, okay, the intensity of the transmission. Which mainly is, okay, just can become, yes, okay, a new intensity of an incidence because it traveled towards the next boundary. It all dependent upon, it's okay, how much energy is, okay, as reflected back from here. It have, okay, as its own intensity of reflection. Clear? Value mainly says, okay, will produce as, okay, its own intensity of transmission. But various, okay, in this instance, is okay. Let me just use another. Okay. This is our incidence or transmission of incidence. Where we can still say that, okay, yes, this incidence's intensity, that will be equal to the intensity of, okay, yes, our first reflection plus the first transmitted wave. Clear? Where this first transmitted wave here is okay, mainly is okay, just becomes the next incidence, which then is just going to be equal to the sum of this orange reflected wave's intensity. And okay, yes, this transmission here. Where this transmission here is okay, just becomes just okay. New incidence, right? Why new incident? Because it's going to have a different or reduced energy compared to this incidence, which is going to have a reduced intensity compared to this incidence. Clear? Where the sum of this is mainly yes, okay, just going to yes, okay, be equal to yes, okay, the sum of okay, yes, the amount of energy that will be reflected. And okay, that's what may then continue on. As a transmission. And okay, let's here as a reflection. Did that make sense? So any incidences intensity is always going to be as okay equal to the sum of the intensity of the reflection that that incident produces and the transmission or transmitted energy. So like here, this was another incidence, just okay, the amount of energy that I carried was going to just okay be equal to the amount of energy that was reflected added to the amount of energy that was transmitted. And it just goes on like that. Clear? Where yes, okay, when we then just look at the incidences, we can mainly say, okay, as far as the intensity of the incidences, yes, okay, this one here is going to, yes, okay, be the greatest. The next one here is okay, just going to be, yes, okay, lower. And of these three incidences, yes, okay, we can actually say that this incidence is going to be the one with the lowest. Why? Because at each level, yes, okay, they mainly is okay, not lost, but it's okay, gave off some of the energy which was going to be reflected. Which was going to be reflected. Right. So in any case, that's okay, whether we took as okay, this first set here, this second set here, or yes, okay, the third set. The intensity of the incidence is always going to be equal to, yes, okay, the sum of the intensity of the reflection and transmission. Incidence energy is always equal to sum of reflection and transmission. Incidence always equal to sum of reflection and transmission. Where the difference of the intensity of the incidence and transmission. Oh, let's see, yes, okay, reflection first. Is always going to be equal to the intensity of the transmission. Or if you subtract the intensity of the transmission from your intensity of incidence, will be equal to intensity of the refraction. Any questions? Yes, girlies.
No.
Anyone has any doubt? Good. So girls, that was your plane intensities of reflection, transmission, and incidence. Clear? Which means is okay, we just mean is okay, how much energy? Or because that will be related to yes, okay, how much energy is going to be carried. So if you guys already got that, then we can just go on to yes, okay, what comes next. Because if we say that, okay, yes, the intensity of incidence is taken as a total of what we can say is okay, 100% or 1. Then we mainly as okay, just to say as okay, that this here is going to be as okay, equal to as okay, the sum of two energies. One is going to as okay, be as okay, what we'll call intensity, reflection coefficient. And the other is going to be as okay, the intensity transmission coefficient. Did you guys get that?
Yes.
So what is actually as okay, the difference here? Now goes when we say as okay, intensity transmission coefficient. The intensity means okay, just means okay, concentration of energy per area in the reflected wave. But here's okay, the coefficient mainly is okay, that's going to be accounting for a percentage of the intensity of incidence. Likewise for your transmission. So intensity is intensity, concentration of area of energy or power per area in the transmitted wave. Where okay, as the term coefficient again here is okay is going to just okay stand for the same as it did over here. There will be as okay the percentage of the intensity of the incidence. Okay, but again, still yes, okay goes. We can still say that okay, yes, these two percentages here. There is the percentage of your intensity coefficient. Sorry, reflection coefficient. Whereas okay is the intensity of the transmission coefficient. The sum of these two here, when we add these two percentages up, it's always going to yes, okay equal 100%, which will be as okay the percentage of your incidence. Just as we said earlier, that okay, yes, when we add the intensity of the transmission, that is always going to add up as being yes, okay, or become equal to the intensity of the transmission of the incidence. Okay, so when we add the intensity of incidence or reflection is added to the intensity of transmission. That will always be equal to the intensity of the incidence. Clear? Whereas if we talk about the intensity reflection coefficient and or intensity the transmission coefficient, it is just going to be as okay, how many percent of the energy carried by the incidence becomes a reflection, and how many percent of it then will just okay just continue on as a transmitted wave. But whenever it's okay, these two here are going to be added up, it's always going to make up 100%. Just like okay, as we add up these two intensities down here, it's always going to be equal to the intensity of the incidence. Clear? So that's the main difference between yes, okay, intensity reflection and intensity reflection coefficient. That intensity reflection coefficient is just how many percent of the incidence becomes a reflection. Whereas okay, here is just talking plainly about yes, okay, the straightforward value of intensity of the incidence. Oh, sorry, reflection. Here we can make it as okay, here this unit would be as okay, the unit for this one here will remain yes, okay, just be yes, okay, the plane unit of intensity. Likewise, okay, as the unit for this one here was still going to be as okay, the plane unit of intensity. So what's going to be as okay, the unit here. Whereas your coefficients just okay, they are either of these are going to be percentages. Percentages of what? of the 100% of the incidence intensity. Where you add this percentage with this percentage is always going to become equal to this percent, 100%. And or if you, for instance, okay, subtract the intensity of the reflection coefficient from the 100%, that would just tell you how much or how many percent of the incident then will continue also as a intensity transmission coefficient. Or, as we said, if we subtracted the intensity transmission coefficient from the incidence of intensity of the incidence, which was 100%, it was going to tell us, okay, how many percent of the intensity was going to, as okay, be reflected back, which will become the intensity reflection coefficient. Did you ladies get that? Okay. So the main difference between intensity coefficients versus plane intensities is that, okay, as the coefficients mean, just talk about how many percent of the incidence becomes a reflection, how many percent of the incidence becomes a transmitted wave. Whereas, okay, you don't have reflections, or okay, you don't have as okay coefficients. It may as okay, just going as okay. Or incidence is okay. If this was your transfer, it's okay. You had a reflection. They may ask, okay, what is the transmitted? They may give you, yes, okay, the value of the intensity incidence, and okay, the transmitted, and ask you, okay, what is the reflected? So likewise here. Okay, but then you just have to make sure that, okay, as you walk, keep an eye open for, yes, okay. Whether it says, okay, is a coefficient or whether it's plane or regular intensity. Did you girls get that? Now, just your typical values for, yes, okay, for your intensity transmission coefficient and your intensity reflection coefficient. What they mainly say is that, okay, yes, the intensity reflection coefficient is max 1. So 1% or less of your incidence intensity, which mainly as okay, will make as okay, you can say it's okay, the intensity reflection coefficient 99% or more. But the thing is that if you said, okay, as if we had an incidence of intensity reflection coefficient of 1%, then okay, as the intensity transmission coefficient is going to be as okay, 99%. Because okay, these two percentages here should add up to give us 100%. Right, okay. Or at the other hand, if he said that, okay, yes, we can just play a little around with the values, just as okay for, say, yes, okay. If 2%, or let's just okay, say, yes, okay, 20%. Well, okay, that's our intensity reflection coefficient. And they may just ask, yes, okay, what is going to be, yes, okay, your transmission intensity transmission coefficient. You can mainly say, okay, you can say, okay, 20% means, okay, subtracted from 100%. That will give you, okay, what the transmission coefficient will be, which in this case, it will mean is, okay, be 80%. So what did that mean? That, okay, 20% of the amount of energy that was transmitted by the, produced in the form of an incidence, reflected back, and 80% of the incidence's intensity is, okay, continued on as a transmission. Right. Or they could just have said, well, okay, you know what, my dear? Well, okay, as you have a transmission incident coefficient of, let's say, 60%. There your intensity transmission coefficient. And they may just ask, yes, okay, what is the transmission, or what is the intensity reflection coefficient? Now that's just going to be as, okay, yes, okay, you can say yes, okay. Subtract 60% from 100%, which means yes, okay, just will give you yes, okay, 40%. Which mainly meant that, okay, as in this case, yes, okay, 40% of the total energy carried by the incidence was going to reflect back, and mean is, okay, just cause 60% to get transmitted. Okay, so it is just a matter of, okay, simply adding up the numbers that you have or subtracting them. Did that make sense, girls? But you have to, yes, okay, be able to, yes, okay, figure out whether you need to add or whether you need to subtract. How are you going to be able to, yes, okay, how to be able to figure that out? Based on, yes, okay, the way that the question is being put. Did that make sense? Okay, girls, another thing. You may be given, yes, okay, you can say, yes, okay, plain intensities. Right, okay. They may give you, yes, okay, intensities and say, well, okay, this is your incidence intensity. This was the reflected intensity. But what is your intensity transmission coefficient? Now you got to be careful here. Right, okay, because then it's not just a matter of, okay, it's adding, or sorry, you can say it's like subtracting the two intensities that you got. But after that, you actually need to, okay, say, well, okay, this much percent became a transmission. Okay, so I assume, yes, okay, that they have questions like that in the what the blue have to call, yes, okay, at the end of the chapter, or yes, okay, in the exam review. Clear? Likewise, you can begin with, yes, okay, attenuation, oh, sorry, attenuation, sorry. You can say, yes, okay, you can be given exact, yes, okay, values of the coefficients. And say, okay, this is yes, okay, your transmission coefficient. This may be, yes, okay, the reflection coefficient. Well, okay, they have to add up to become 100. So they may just give you one of the values and say, okay, this is your intensity reflection coefficient of an intensity of this much, of an incidence of this much intensity. And then they may ask you whatever. They may ask you to calculate the intensity transmission coefficient. And or it's okay, your simple transmission intensity. So in some instances, okay, a problem may as okay need more than just one piece of math to be done. But does anybody have any questions?
No.
Good. Just to see, yes, okay, if we got it, we can just look at the, yes, okay, there are 2 questions that they have on page 94. And maybe it's okay, sorry. Maybe it's okay, we just play a little around with it. Around with them, okay? So let's just look at question number 1 now. First, we're just going to just, okay, solve it as it is asked in the book. Okay, so what do we have? A sound wave with an intensity of 50 watts strikes a boundary. Now goes, it is not directly, yes, okay, giving you the direct words of, is this a transmission, is this a reflected, it is a incidence. But you just have to figure that out from the words. But yes, okay, if you look at it, it says, okay, it's 50 watts per centimeter square, right? Okay, this is the intensity of, okay, as a wave. And okay, the main yes, okay, just make this here, and this is because this is okay, it strikes a boundary. Did that make sense? Did that make sense? Right, okay. Now the next thing that they ask, or the next part of the question is, and it's totally reflected. Now when you say, okay, totally, that's going to say, okay, mean all of it. All of it is reflected. Which means you mean that, okay, as the intensity of your reflection here is going to be as, okay, the same as this. Or whatever energy this incidence here carried is going to be reflected back, right? Did that make sense?
Yes.
Yeah.
Good. And what then they asked you at the last is, okay, yes. Now here be watchful because they are not, these were plain intensities, right? But they ask you, yes, okay, what is the intensity transmission coefficient? Yeah, okay, mainly because it is a coefficient, it has to, yes, okay, be, yes, okay, in terms of percentage. And as we have said, yes, okay, in terms of duty factor, yes, okay, percentage is most likely, yes, okay. But here we have, it will be unitless. Okay. But you can say, yes, okay, you left your home with, okay, 50 apples. Okay. And before, yes, okay, you walked out of your car with 50 apples. You got to the school door, and then you go back and put those 50 apples back into in your car. You're not going to be carrying any apples with you, right? Okay. But then they have, okay, different answers. They go 50 watts per centimeter square. That cannot be the case. Because whatever you brought, you take back. Clear? That was going to be, yes, okay, if there has been, yes, okay, if your intensity of the reflection was going to be as okay 0 watts per centimeter square, or we can say okay that there was no reflection at all, then okay you can say it's okay the intensity of the incidence and the transmission of the intensity of the transmission was going to be equal because there was no incidence or reflection. Sorry. Clear? It can't be 25 watts per centimeter squared. That would have been a correct answer if it said half of the energy is reflected. Or they may have said that, okay, you had a intensity reflection coefficient of 50%. What would that 50% mainly mean? That, okay, 50% of, okay, your 50 watts per centimeter squared here was reflected, which is going to be, as okay, you could then say, okay, then that would have been, as okay, 20 watts per centimeter square. And in that case, that's okay, this would then have been, okay, as okay, so 20 watts per centimeter square. But that's only going to, as okay, with the ask, okay, what is the intensity of the transmission? Okay, they go C as 0 watts per centimeter square. Now, that is wrong, mainly because they ask you about, as okay, what is the coefficient? The intensity of, yes, okay, your transmission here is 0 watts because all of the energy was transmitted back. So there's actually, yes, okay, no energy being transmitted. Yeah, it can't be 100%. That was mainly as okay, what we had primarily as okay in the transmission or reflection coefficient. So as okay here, the answer is 0. Clear? 0 watts per centimeter square would have been correct if they just asked what is the intensity coefficient? What is the intensity of the transmission? Or mainly because it's okay to go with coefficient is going to be okay, how much of the incidences intensity in terms of percentage is going to okay be transmitted, which is okay in many cases it will be unitless because we don't have a unit here. Did that make sense? Now, if you just look at question number 2, well, okay, the numbers and so on so are pretty much the same. So we mean it's okay, so it says it's the same as okay. A sound wave with an intensity of 50 watts per centimeter square strikes a boundary. So what you get from this, that's meaning is okay that they give you is okay the intensity of the incidence. Indirectly by meaning is okay, well, okay, that's going to be as okay the intensity of okay as a sound wave that strikes a boundary. Clear? Just keep in mind the word boundary can be replaced by reflector. It can be replaced by tissue, which was 50 watts per centimeter square. Now, the again says, okay, it is totally reflected. So simply again, it's okay when we say that it is totally reflected, well, okay, we have a reflection. And the intensity of that reflection is going to be, yes, okay, the same here because it was totally, which was going to be, okay, 50 watts per centimeter square. Clear? Okay, and that's meaning, yes, okay, what they just asked, okay, yes, what is the reflected intensity? It's in the question if you, so really as okay, although you see numbers, there's no really math. Now girls had to ask you, yes, okay, had they changed the wording of the last sentence and say, what is going to be as okay, your intensity reflection coefficient. That could have been yes, okay, 100%. And or that intensity 100% correct. I think it's okay. One. Did you girls get that? Yes, girls. Now let's see. So we can make up a question here. And we can say, okay. So we can say, okay, a sound wave with an intensity of 20 watts per centimeter squares. Propagates towards a reflector. Five percent of the energy is reflected. Now comes, yes, okay, the question. What is the transmission coefficient? Yes, girls.
Would it be 95%?
Exactly. You didn't really need to do any math besides, okay, subtracting 5% from 100%. Clear? Now, this was just, okay, your initial wording of the question. That this is, okay, a sound wave is, okay, with an intensity of 20 watts per centimeter square propagates towards a reflector or tissue. 5% of it is reflected. Now I made and ask you, it's okay. Another question. What is the synchrological intensity of the reflection? Now, does anybody know how to do that math? Yeah, Dixon, I know that. But let some of the other girls.
Can you put it back up for a second?
I'm giving you a number and I ask you just, okay, calculate its percentage value. Yes, girls. I can put it up. So yes, okay, I can even read it out for you so you're not confused. So a sound wave with an intensity of 20 watts per centimeter square propagates towards the reflector. So what does this one here makes? This actually is okay as the intensity of your incidence, right? But what you mainly is okay, just are given here is okay as 5% of the energy is reflected. Okay, this 5% is mainly as okay 5% of your incidence. And when that's okay, if that's the case, what is going to be as okay the intensity of your reflection?
Would it be 1?
No. Okay, girls. This is how you do it, right? To calculate the intensity of your reflection here. You check this, which was okay as in this case, the intensity of your incidence. It really doesn't matter. And then you may just okay multiply it by the percentage. And since it says okay, this value here is okay, is a percentage of this, and you want to find its value, you actually it's okay, we have to divide this whole thing here, it's okay by so this mathematical is okay. It's going to just okay in this case give us okay what the intensity that we are looking for is going to be. Okay, so there's different ways of doing it. When it comes out to the same, you can say okay, let's discuss this. So what do you have? You have okay as or you end up with 2 multiplied by 5, which becomes 10, which then is okay, just divided by 10. And okay, yes, Abigail, yes, okay, you were right. Sorry. So 10 divided by 10 becomes 1. And then just be watchful here, girls, because okay, this is just okay as okay. This is not going to be 1%. But it's going to just okay be 1 watt per centimeter square. Did that make sense?
Yeah.
And oh, yes, okay, you could be giving yes, okay, the same data, and they may just have asked, yes, okay, what is the sorry, what is okay, yes, the intensity transmission coefficient. Where you may, yes, okay, could do it a long way, yes, okay, first calculate this 1 watt per centimeter square. Say, okay, 1 subtracted from 20 is going to be as okay. Oh, we already did the transmission. Okay. All right. That's the playing as okay, transmission intensity. Or you can do it saying, okay, well, okay, if this is 5%, the transmitter has to be 95%. So yes, okay, it's going to mean it's okay, just be the very same. That 20 is then multiplied by the 95%. Or 95, right? Okay. I mean, it's okay because this is a percentage of this. You multiply the whole thing here, it's okay by 100. Right, okay. But you mean you can say that, okay, yes, 95 times 2 becomes 190. But then it's okay, sorry. Divided by 10 becomes 19. Which is okay, yes. The intensity of your transmission. And you see it as well here that, okay, yes. When this is added with this, it equals this. So that's okay, different data that you can be given. And okay, as be asked, yes, okay, calculate different things. So it doesn't really matter, girls. That's okay when you're out there and they say, okay, yes, this pair of shoe here is okay, there's 35% off the check price. Whatever the price was. You can actually say, well, okay, the price was originally, it's okay, $40. But if you take 35% out of that, you may say, okay, how much is it going to be less than $40? You can calculate that number. Multiply that by the percentage, divided by the 100. And that will tell you, okay, how many dollars they will take off the shoes. So if the dollar is okay, the shoes was originally 45%, $44. Okay, you can say it's okay, 30% off. So 30 times 40 is 1,200. Right, okay, but where the 00 just cut with the 00. So they take $12 off that pair of shoes. So that $4 pair of shoes is now going to cost you $12 less than 40, which is how much? If you take $12 from $40, what is it going to be the price that you pay?
28.
28. But just keep in mind you also have to pay. Okay, well, that's going to see also get the upfront pay price, right? Okay, and then you also get, of course, Uncle Sam is going to just okay charge you as well, right? Right, girls? So yes, okay. All the money that you are able to just okay determine that you will be able to save because okay, well, that's reasonable. I didn't want to pay $40 for it, but okay, 28, you can't beat it. Okay. But make sure that you, yes, okay, keep your eyes open. Okay, and you may not directly begin as okay, the words like okay, intensity, transmission coefficient. They may just say, okay, reflection is 5%. Reflection is 3%, or transmission is 2%, or something like that. Clear? So differentiate that from, yes, okay, regular, yes, okay, intensities. Any questions, girls? No? Okay. And ladies, just keep in mind that, okay, yes. Well, okay. So that's pretty much it. So tomorrow, yes, okay, we'll be, yes, okay, finishing off with this chapter here, okay? And we mean, yes, okay, just left with, okay, as reflections of and transmissions of oblique incidences. So that's mainly, yes, okay, what we briefly talked about today. Okay, girls? Unless somebody has any questions. Yes, girls?
No.
Okay. Okay, girls, then I guess I see you ladies tomorrow. Have fun.
Okay, thank you.
Thank
You're
you.
welcome, my dear.
Thank you. Bye.
Bye-bye, dear. Okay, okay, just a second.